Iteration is a fundamental building block of all programs. It is the ability to execute a certain code repeatedly. In this section, we will focus on a few examples of iteration processes in Python. To begin, we have prepared a list called even. It contains all the even numbers from 0 to 20. Imagine we want these numbers printed out, so we can write the following. For n and even, colon, which would mean for every element n in the list even, do the following. Print that element. In this case, n is called the loop variable. It is not required to have called it n. Any other name would have worked fine.
The phrase print, open parentheses, n, close parentheses, acts as the body of our loop. Don't forget, it should be indented to run the loop properly. The operation in the loop body is performed once for each element in the even list. Now, let's go over the steps implied by this piece of code. The loop starts by taking an element n from our list. Then, the computer executes the body of the loop. In our case, it will simply print that variable. When the computer is done with this operation, called iteration or pass of the loop, Python will go back to the for statement and pick the next element n that is in the even list. It will then print out, and so on and so forth until the loop body has been executed for all available elements in the list. Right, let's apply this code to see the outcome. Exactly as expected. All numbers were stated in a column. What if we wanted to see them ordered in a single line? A comma after the element n in the parentheses after the print function, and an n parameter with a value of an empty string will help us achieve that. Note that to specify an empty string, you need to type an empty space between a pair of double quotes by pressing the spacebar on your keyboard once. Thus, the comma and the n parameter will indicate every next element from the loop should be placed with a distance of one space on the same row. And if the elements you're about to print are too long, they will be displayed on multiple rows in the output cell. But you don't need to worry about that at the minute. This was a short but important introduction to the concept of iteration in programming.
See you in the next video, and thanks for watching. The same output we obtained in the previous lesson could be achieved after using a while loop instead of a for loop. However, the structure we will use will be slightly different. Initially, we will set a variable x equal to 0, and we'll say, while this value is smaller than or equal to 20, print x. But please be very careful, and I mean it. If you leave the code until here, you will run into an infinite loop, and your computer will crash. This is a situation you want to avoid, right? So, be very careful. Since x will always be smaller than 20, your loop will be infinite. It will iterate the same variable repeatedly. This is what we did here with x equals 0. And always is not what we want in an iteration. We want to get the loop to end. What is supposed to succeed the loop body in the while block is a line of code that specifies a change in x, or what has to happen to x after it is printed. In our case, we will tell the computer to bind x to a value equal to x plus 2. Let's see if it works. Awesome! This is much better. Actually, there is a term for what we just did. In programming terms, adding the same number on top of an existing variable during a loop is called incrementing. The amount being progressively added is called an increment. In our case, we have an increment of 2. Furthermore, the Python syntax offers a special way to indicate incrementing. X plus equals 2 shows we are incrementing the value of 2 on top of the base x, just as if we had typed x equals x plus 2. As you can see, the two outcomes are the same. To conclude, whether you will use a for or a while loop will depend mainly on your personal preferences. What matters is that your code does not crash and provides correct results. Right? Thanks for watching.
Later in the course, we will need to randomize data points and lists with data points, and that's when we'll be able to use Python's built-in range function. It can help us by creating a Python range object, which actually is a mere sequence of integers.
The syntax of the function is the following. Type range and in parentheses, mark a start, stop, and step value. The start value will be the first number in the list. The stop value will be greater than the last value in the list. It is going to be equal to the last number plus 1. Just classical Pythonic logic, right? The so-called step value represents the distance between each two consecutive values on the list. The stop value is a required input, while the start and step values are optional. If not provided, the start value will be automatically replaced with a 0, and the step value would be assumed to be equal to 1. You could also remember the stop value as most important, the start value as less important, and the step value as least important.
For this reason, range of 10 will provide a sequence of 10 elements, starting from 0, implied after not indicating a start value, and ending at the 10th consecutive number, number 9. Python, however, will not display the sequence in the form of a list. Instead, it will show this as a range 0, 10, which stands for a range object with a start value of 0 and a stop value of 10. To display the sequence in a list, we can take advantage of the Python built-in list function, using this very same range function as an argument. In that case, we will obtain a list containing all integers from 0 to 9. The trick that was just introduced to you is something you will need to have under your belt if you are using Python 3 and want to check the values generated by a given range function. Also, remember that Python 2 will handle the situation in a different way. It will directly create and display the sequence as a list, as opposed to a range object. We will show how this can be done later in this lecture. And that's pretty much all you have to know about the range function in Python 2 or 3. That said, let's take a look at two other examples. In another cell, if for instance, in the range function, we declare as arguments 3 and 7, Python will accept 3 as a start value and 7 as a stop value of the range. So we obtain a list from this range function. We see that we have 4 elements, 3, 4, 5, and 6. Good. In another example, we may want to specify a step value in a range. To do this, we must choose the first 2 arguments as well. So let's obtain a list with all the odd numbers from 1 to 19 included. I will start with the number 1, and the list will end with number 19, which equals the stop value 20 minus 1. To state the odd numbers only, we must designate a step value of 2. As we execute this cell, we will obtain the corresponding range object. To see the values displayed in a list, we can use the same range function as an argument of the list function. Thus, we'll obtain the desired result, which means that we have worked correctly.
This is how we can create lists with Python's range function. In our next lecture, we'll see how it can be applied in practice. Thanks for watching.
Now that you know what the range function does, let's see it in a for loop. To print all the values from 2 to the power of 0, 2 to the power of 1, and so on until 2 to the power of 9, we can use the following code. For in range of 10, print 2 $n, written in parentheses. I will also have to insert a comma and specify an n parameter with a value of an empty string after n, because I would like to see the output on a single line. Good. I guess you can agree it was not necessary to designate the name of a list that exists in our code. using a sequence of numbers generated by the range function is going to work too.
Now, let's be brave and create an iteration that includes a conditional in the loop body. We can tell the computer to print all the even values between 0 and 19 and state odd in the places where we have odd numbers. Let's translate this into computational steps. If x leaves a remainder of 0 when divided by 2, which is the same as to say if x is even, then print x on the same line. Else, which means unless x is even, or if x is odd, print odd. Lovely! This is an example of a combination of an iteration and a conditional in Python. There are two main ways to program a loop, and until this moment, we paid attention only to the first one. We have a list X that contains the numbers 0, 1, and 2. We saw we can print out each of its elements by typing for each item in the X list, print out that item. The second way finds its practical application in more sophisticated codes. Its structure takes advantage of the range and len functions in the following way. For each item in a range that goes through the elements from the list X, that is, len with an argument X, print out each item. If we do this, the variable item will loop through a new list created by range, and that has as many elements as the X list itself. Please note that in this situation, the second line of our code needs indexing to extract each item from the X list. In practice, we will print out the element at position 0 from the list X, then the element at position 1, and finally the element at position 2. To conclude, both approaches can lead to the same outcome. Although the second one looks unnecessarily complicated, in advanced coding, it might turn out to be a lot more useful. So, it is important you know both. Don't skip the exercises that come with this lecture, as they will reinforce what you've learned here. Thank you for watching. We use iterations when we have to go through variables that are a part of a list. In this lesson, I'll show you how to count the number of items whose value is less than 20 in a list. First, define a function that takes as an argument numbers, where numbers will be a certain list variable. The trick is to create a variable that, so to speak, departs from 0. Let's call it total. The idea is that when certain conditions are verified, total will change its value. This is why in such a situation, it is appropriate to call this variable a rolling sum. More technically, when we consider x in the numbers list, if it is smaller than 20, we will increment the total by 1. And finally, return the total value. This means that if x is less than 20, total will grow by 1. And if x is greater than or equal to 20, total will not grow. So, for a given list, this count function will return the amount of numbers smaller than 20. Let's verify if this function works properly. In this list, we have 4 numbers that are less than 20, right? Let's check that out. Great! Now, if I add 17, for example, somewhere in the list, the outcome will adjust accordingly. 5. Exactly. Perfect. By the way, look how the whole if statement is indented even more to the right. This allows us to separate it logically from the rest of the code in the cell that refers to this function. If you are eager to know how to iterate over a dictionary in Python, and I am sure you are, you will see this in our next video. Thank you for watching. Let's look at something a bit more challenging, iterating over a dictionary. We have a couple of examples here. The prices of a box of spaghetti, of a portion of lasagna, and of a hamburger are stored in a dictionary called prices. Jan went to the supermarket and bought 6 boxes of spaghetti, 10 pieces of lasagna, and no hamburgers. This data was stored in a dictionary named quantity. Our problem is, how much did Jan spend in the supermarket? Well, it is obvious you'll need to multiply the quantity of each food by its price. You must have noticed our dictionaries have exactly the same keys. We should exploit this. The procedure to go to the box of spaghetti in the first dictionary and take the value of 4, then get the value of 6 from the quantity dictionary, and then multiply those two must be repeated for each food product. That must ring a bell. I am sure you probably think the same. We need a loop. Okay, that's clear. But what are we going to do with it? What is the loop's body going to contain? Before anything else, some variable must account for the amount of money spent, right? Let's implement a well-known trick. I'll create a rolling sum called money spent, which will initially assume the value of 0. So, we can start by iterating over each item in prices, I in prices for short. At every step of the loop, I would like the money spent variable to grow by the product of the price and the quantity of a certain good I. And that should be enough. Let's print the result to check whether we are working correctly. Apparently, yes. Wow! Such a simple problem in terms of mathematics required to connect knowledge on dictionaries, iteration, and creating a variable with an increment. So, from a programmer's perspective, the problem looks different. The good thing is that, at the end, this whole thing boiled down to a mere 4 lines of coding. As a side note, do you realize that if we put quantity instead of prices here, the outcome will remain the same? So, what is the conclusion? It does not matter if you loop through prices or through quantity, because the two dictionaries contain the same keys. And this is the reason this loop works correctly too. This section was a bit more complicated, wasn't it? The exercises you will find after this lesson will be more challenging, so it is quite important you solve them. Thanks for watching.